Alaikum. This is 11th chemistry, and our today's lecture is about Charles law. As we have already discussed this Boyle's law in our previous lecture. Now, and today we are going to discuss this Charles law, and this Charles law. It gives us the effect of a temperature on the volume of a gas at constant pressure. So this was given by Charles in 1787, and it was further elaborated by Joseph Gay-Lussac in 1802. And both these Charles and this Gay-Lussac, they came up with a generalization that is called as this Charles law, and it is stated as that you can see here that is the volume of a given mass of a gas increases or decreases by 1 by 273 of its volume at 0 degree at 0 degrees centigrade for every 1 degree rise or fall in temperature, provided the pressure is that is and that pressure is kept constant. So mathematically we can this Charles law, we can put it like this. If we have got this V0 is the volume of the gas at a temperature of 0 degree centigrade, and when the temperature is increased to T degree centigrade, in that case the volume also increases and it becomes Vt. So we have got this is the volume. Vt is the volume at T degree centigrade, and V0 is the volume at 0 degree centigrade. Now then according to Charles law, we can say that this is Vt is equal to V0 plus V0 over 273 into T, where Vt is the volume at T degree centigrade and V0 is the volume at 0 degree centigrade, and T is the temperature. Now volume at 1 degree centigrade, that is when the temperature is 1 degree centigrade, it is V0 plus V0 over 273 into 1. Similarly, we have got volume at 10 degree centigrade or V10, it is V0 plus V0 over 273 into 10. Then we have got the volume at 100 degree centigrade or V100, it is given by V0 plus V0 over 273 into 100. Now when the volume is when the temperature is kept minus 1 degree centigrade, that is volume at minus 1 degree centigrade, in that case we get Vt is V0 minus V0 over 273 into 1. Similarly, volume at minus 10 degree centigrade is given by V0 minus V0 over 273 into 10, that is the or minus 10. And similarly, we have got volume at 270 minus 273 or V minus 273 is given by V0 minus V0 over 273 into 273, that comes equal to 0. This means that we can say that the volume of a gas or any mass of a gas at minus 273, it becomes 0, that is the gas will cease to exist at this temperature. Now the same conclusion can be reached or can be arrived at if we plot this graphically, that is we plot this volume against the temperature. Temperature is along this x axis, while as the volume is taken along this y axis. Now keeping the pressure of this gas constant, a graph plotted between the temperature and this volume is, I have shown it here, you can see here. Now as the temperature first, when the temperature increases, the volume also increases. Now with the decrease in temperature, we see that the volume also goes on decreasing, and upon extrapolation, we see here shown by here the dotted line, you can see here the graph meters the temperature excess at a temperature of minus 273 degrees centigrade, or more precisely we can say it is minus 273.15 degrees centigrade. So the volume of every gas becomes 0 at this temperature, that is minus 273. You can see here how this meters this temperature at this volume becomes 0 at this temperature. Now as far as absolute zero or Kelvin scale of temperature is concerned, now this hypothetical, we can say hypothetical temperature of minus 273, at which we see the volume of any gas becomes 0, we call it as absolute zero, and it was Lord Kelvin It was Lord Kelvin who gave this scale of temperature. This is called as Kelvin scale, or we also call it as absolute scale, in which the lowest temperature is absolute zero, that is 273 Kelvin. Now the temperature, now the size of the degree, now the size of the degree on the Kelvin scale is same as on the centigrade scale. Now the temperature on this Kelvin scale, it is noted as TK, and we see Kelvin and the Celsius scale, they are related to each other. You can see here, this is T Kelvin is equal to, this is T degree centigrade plus 273. Now as far as the freezing point of water is concerned, in Celsius scale we see that it is freezing point is 0 degree centigrade, while as in Kelvin scale it is 273 Kelvin. Now similarly, the boiling point of water we see in centigrade scale, it is 100 degrees centigrade, whereas in Kelvin scale it is 373 Kelvin. Now however, it is not possible for any gas to achieve this temperature, and that is minus 270 73 or absolute zero under any condition, because the volume becomes zero. In other words, we can say that the gas doesn't exist. Actually, a gas changes to liquid state before attaining this temperature. So absolute zero is only, it is a hypothetical temperature for a gas. Now alternate form of Charles law, you can see, I have shown it here. It is Vt is equal to V0 plus V0 over 273 T. Now where Vt is the volume at T degree centigrade and V0 is the volume at 0 degree centigrade, or we can say V0 into 273 plus T over 273. Now we know that 273 plus T, that is given by T Kelvin on Kelvin scale, and 273, that is designated by T0. Now so this equation becomes, we can write this equation as Vt is equal to V0 over T0, V0 T over T0, or Vt, we can put it like this: Vt over V0 is equal to T over T0, or we can say V over T is constant at constant pressure. So volume is directly related to temperature at constant pressure. Now we can also define this Charles law like this, that the volume of a given mass of a gas is directly proportional to absolute or Kelvin temperature at constant. This is the alternative form of this Charles law, that is volume is directly proportional to absolute or Kelvin temperature at constant pressure. Now if let V1 be the volume of a gas at a temperature of T1, and similarly if we keep the pressure of the gas constant and the temperature is increased to T2, in that case the volume becomes the new volume becomes V2. So we can write, therefore, according to this law, Charles law, we can say V1 over T1 is equal to V2 over T2. Now graphical representation, we can you can see here, graphically here shown it, that Charles law can be represented graphically by plotting volume against the Kelvin temperature, keeping the mass and the pressure of this gas constant, and we get a straight line. You can see here it is a straight line, which shows that volume is directly proportional to the Kelvin temperature. Now we can also plot a number of curves between volume and temperature at different pressures, and these are called as isobars. And the nature of the curves, you can see here, it is same. You can see in all these cases the nature of the curves is same. Now experimentally, Charles law can also be verified by determining the by determining volume of a gas, volume of a given mass of a gas at different temperatures, keeping the volume, keeping the pressure constant. You can see here that the v by t value, that is volume over temperature value, is expected to it is expected to remain same in all these cases. You can see here temperature, at a temperature it is 273, then we have the volume, at volume is 775, and v by t, that is volume over temperature, that is 2.84. Now if the temperature is now increased to 293 and 293, then volume becomes 832, and again we see volume over temperature, that is 2.84. Now if we increase the temperature 313, the volume again increases, it increases to 889, and v by t value remains the same, that is 2.84. Similarly, if we increase the temperature further, that is to 333, and the volume again becomes, it gets increased, and the new volume is 946, but v by t value remains, it remains the same, that is 2.84. Now as far as so these are the various this is you can see it, v by t in all these cases it remains constant. Now as far as this importance of this Charles law is concerned, Charles law, we see that it has got its application in case of hot air balloons, which are used in sports, and also for meteorological observations. According to this law, we see that that a gas expands, it expands on heating, since the mass of the gas remains unchanged. Therefore the number of molecules per volume, per number of molecules per unit volume, or the density of the gas decreases on heating. In other words, hot air is, we can say that hot air is less dense than the cooled air. This enables these hot air balloons to rise up by displacing the cooler air of the atmosphere. So this is about this Charles law. So it is for today. Thank you very much.